Welcome to the In Amena video tutorial about concentrating solar power technologies. This lecture aims at giving you an overview about the In Amena project, which is the framework of these tutorials. It is my honor to make this presentation and to bring in my experience to this work. I am a mechanical engineer and have been working in the solar business for the last 13 years. Since January 2010, I am acting as In Amena project manager at the German Aerospace Center. I would structure my presentation in such a way to give you an overview about the project background, its partners network, its structure, modules, and finally I will give a summary of the project including an outlook. So I'll start with the background for the project. And here, by the year 2050, we're gonna know that there will be around 10 billion people living on Earth, in which 90% of them will be living in a distance less than 3,000 kilometers from the so-called world's sun belt. For example, we have here the North African and Middle Eastern deserts. When exploiting the solar energy potential in this region for electricity generation for world's population, it is estimated that only a tiny area of about 20 square meters should cover the electricity requirements of one human, according to the Desertec concept. Reflecting this figure on the recent world's population, this gives only 3 per mil of the desert area should cover the recent electricity demand for the entire humanity. Therefore, the North African Sahara is indeed a natural treasure, not only for its peoples, but also for the neighboring nations. The aim of this project is to support the efforts leading to utilize the huge potential of solar energy and other renewable energy resources power generation in the MENA region. Such environment-friendly generation of power shall, besides supplying electricity, decrease the CO2 emissions and therefore save the planet. Due to the promising results in case of their implementation, the In Amena project aims at particularly supporting the sustainable implementation of concentrating solar power technology, or the CSP, in the MENA region, in line with the well-known Desertec concept. Our contributions to achieve the objectives of the project focus on the permanent support for the region's people, on the technical level, of course, the improvement of needed technologies, and support the dissemination of the CSP technologies. The In Amena project was initiated by the German Aerospace Center and is supported financially by the German Federal Foreign Office. The construction of CSP power plants should be well planned and executed because of the fact that, in contrary to the conventional power plants, the CSP power plants require high investment costs, and therefore any failure in the planning would be difficult and expensive to correct later. In this case, the project profitability will be affected. It was estimated that good or bad planning would result in 10 to 15% gain or respectively loss of the solar field efficiency. So, for such a long-term investment, we have to make sure that the project is well planned and executed also. Measures such as capacity building and development of the technologies to check and improve the plant's efficiency should contribute to the success of the implementation of these technologies. I'll get back now to the In Amena project to present its network of partners. So the project was able to form a network of about 45 partners from mainly 5 MENA countries and Europe since its start. This network consists merely of entities which are dedicated to develop the solar energy in their countries, such as R&D facilities. I'm talking about governmental bodies, universities, private companies, and also even individuals. So this is reflected in Morocco, in Algeria, in Tunisia, in Egypt, in Jordan, on the regional level, and finally in Germany. More partners from more countries will be invited to join the In Amena network in the near future. On this slide, you can see the structure of the In Amena project. So it has 3 main modules based on the identified needs and therefore activities. Module number 1 deals with the efficiency improvement of CSP technology. Measurement technologies to qualify the CSP power plant have been developed and should be implemented according to this module. Moreover, the creation of local test and R&D infrastructure at the partner institutions is treated in this module. Module number 2 focuses on people. In its framework, CSP teaching materials for universities as well as training materials for technical were prepared. Finally, several training courses for engineers, planners, and technicians were organized. Module number 3 focuses on supporting a successful project planning, facilitating the provision of reliable solar data for project planning, and on the initiating of the dissemination of information and conjoint researches with MENA partners. Now we'll go through the single modules for more details. I'll start with module number 1, technology. So the main objective of this module, as mentioned, is the development of measurement techniques to qualify CSP power plants and control the quality of their components. I would like to mention here 2 major developments in this regard. First, the Q-Fly technology for optical qualification, and secondly, the calibration bypass technology for thermal qualification of CSP solar fields. Get now more information about these technologies. Here you can see the Q-Fly technology, which was developed for conducting the so-called deflectometry measurements for optical qualifications of the solar collectors. This technology is based on the usage of an aerial vehicle to measure the entire field. Its ability to measure also during the operation is seen to be an advantage for permanent control of the quality of the solar field. Here we can see the calibration bypass, which is a new method developed by the German Aerospace Center to conduct on-site thermal check for the solar field. The installation is done in such a way that all required sensors are fixed on external pipe, and this, its turn, will be fixed to any location in the power plant. This is shown in the diagram below. The bypass allows the measurement of all flow parameters with high accuracy during the operation of the power plant. So this could be used always to improve the operation efficiency of the solar field loops. So I'll get back to module number 1. A significant activity in module number 1 was to prepare mobile measurement laboratory and to deliver it to each project partner. More information about these laboratories are here, in which each laboratory includes devices to perform quality control and qualification tasks of the CSP plant components, such as optical and thermal qualification tasks. Here you see some pictures of these measurement kits. So there are main planned activities in this module, and they are supporting the creation of local test and R&D infrastructure at partner institutions. We'd like also to start performing thermal and optical measurement campaigns with MENA partners at their CSP power plants. I'll go on with the second module, people. So we have in our activities performed 2 capacity building courses for MENA engineers to establish a local know-how base in the region. 2 courses called EMCP01 and EMCP02 were organized at the Spanish PSA in November 2010 and at the Tunisian Technopole in November 2011, respectively. Now we take a closer look at EMCP01. So this 4 weeks capacity building course included practical and theoretical units and was held at the Spanish Plataforma Solar de Almería in southern Spain in November 2010 for 25 engineers from our 5 partner countries. As one of their functions now, these engineers are now acting as knowledge multiplicators in their countries through organizing training courses on the local level. Here you can see some photos that were taken during the course. I'll get back to the main menu, and here the preparation of the MENA CSP teaching materials is an important result of this module and was one of our activities. Get more information about this point. As you can see on this slide, the preparation process lasted about 2 years with the involvement of several parties from Germany and the MENA partner countries. Important milestones such as the orientation, launching, and implementation workshops mark the progress in this preparation process. The MENA teaching materials are being implemented since September 2011 at some of our MENA universities. In this regard, more implementation workshops are planned in the near future. On this slide, you can see that the INAMENA teaching materials cover a wide spectrum of most CSP-relating topics. I'd like to mention here the description of different technologies. For example, we have site assessment study and description, the economics, and we have also information about the maintenance and operation of CSP power plants as part of the teaching materials. Moreover, out of these materials, we are planning to publish a standard reference book in the framework of INAMENA project. We'll get back now again to the main module. We'll continue. So the preparation of expert training materials out of the training materials, so the EMCP01 and EMCP02 training materials was done here as well. And finally, this module included the organization of 2 CSP expert teaching courses in cooperation with regional and national players in the MENA region. So we are talking about a course in November 2011 in Tunisia and another one in Amman in February 2012. What we are planning to do in the framework of the project with the organization of EMCP03 capacity building course for the improvement of thermal efficiency is planned. The organization of further CSP training courses in cooperation also with other or with the same regional and local players is planned. And finally, the preparation of the so-called INAMENA video tutorials out of the training materials to achieve faster dissemination to the target groups is planned and being executed herewith. So I'll move now to the third module, the dissemination. And here we have the following activities. The preparation of coaching material for yield analysis and in project planning methodology was accomplished. The establishment of local contact points for information dissemination at partner institutions is also done. The installation of INAMENA Meteo network to provide high-quality DNI and other metadata is also accomplished partially. Now we'll get some more information about this point. And here you can see the INAMENA meteorological network, which will provide reliable or has to provide reliable weather data to serve the planning and performance analysis of CSP projects in the MENA region. Moreover, it could support the existing satellite weather data. This network consists of 10 high-precision meteo stations to measure the normal, direct, global, and diffuse irradiances with an uncertainty between only 1 to 2%. Moreover, other typical weather readings are also measured. Let's back now to the main menu. So mainly planned in this module are the organization of capacity building courses, but now for project planners and managers based on the coaching materials produced in this module, and conducting conjoint research activities with MENA partners in the region's relative or relevant topics. This is very important here because these topics are really very relevant and it's need to conduct researches in them. For example, we have soiling of reflectors and extension of solar irradiance, aging of materials in desert climates, meteorological data assessment. So we're planning to conduct research with our partners in these topics. So now I come to the last slide of my presentation. I would like to give you a short summary and an outlook of the INAMENA project. So the INAMENA project aims at the sustainable development of CSP technology in the MENA region as part of the global efforts to support the shift to renewable energies and to support the Desertec concept. Over 45 partners are involved in the project. Capacity building is an important focus of the project. Target groups are field engineers and technicians as well as project planners. The CSP teaching materials have been finalized and being implemented at some of our partner universities in the MENA region. A meteorological stations network is partially running and already delivers reliable data. And finally, INAMENA aims also at supporting partners to develop their own test and research and development infrastructure. Now I come to the end of my presentation. Thank you very much for your attention.